Hello students, today we are going to study types of chemical reactions. Now here we have the first one, that is combination reaction. Combination reaction, which is also called as synthesis reaction. Second one is decomposition reaction. Third one is displacement reaction, which is also called as substitution reaction. And fourth one, we have double displacement reaction. So here we are going to study these four types of reaction: combination reaction, which is also called as synthesis reaction; decomposition reaction; displacement reaction, which is also called as substitution reaction; and double displacement reaction. So in this double displacement reaction, we have two types. That is, one is precipitation reaction, and the second one is neutralization reaction. Now, let us study the first one, that is combination reaction. It is a chemical reaction in which two or more elements or compounds combines to form new product. So it can be represented as A plus B gives C. Okay. Now, where A and B are the reactants and C is a product. So here, let's take an example. First one is burning of magnesium ribbon. So magnesium in presence of oxygen, what we get is magnesium oxide. Check if the equation is balanced. So it is not balanced, so we have to balance this. Okay. So this is one type of combination reaction. It is also called as synthesis reaction, wherein two elements combines to form one product, which we call it as synthesis reaction. Let's take one more example. Burning of carbon. So carbon in presence of oxygen, what we get is carbon dioxide. Third one is the burning of hydrogen, is also being considered as a combination reaction. That is, hydrogen is combined with oxygen and what we get is water. So here you need to balance this. So this will be 2H2 plus O2 gives 2H2O. One more example what we can take in this is carbon dioxide plus water. When carbon dioxide is combined with water, what we get is the acid. Yes, it is carbonic acid, H2CO3, carbonic acid. Okay. In this one more example, what we can take is Fe, where it is combined with sulfur. What we get is FeS, that is ferrous sulfide, when it is heated. So these are some of the examples of combination reaction. Second one is decomposition reaction. It is a chemical reaction in which one compound is split up into its constituent elements or simply compounds. This reaction takes place with the help of energy, that is in the form of heat energy, light energy, okay, or electric current. So it can be represented as A gives B plus C, wherein A is the reactant and B and C, these are the products. Okay. So here we have thermal decomposition reaction. That is the decomposition reaction which takes place with the help of heat energy. We call it as thermal decomposition reaction. Now let us study some of the examples. So the first one we have is the calcium carbonate. That is decomposition of calcium carbonate. So when calcium carbonate, which is also called as limestone, when calcium carbonate is heated, what we get is calcium oxide plus carbon dioxide. One more example, what we can take is heating of mercuric oxide. HgO is mercuric oxide. So here it will get decomposed into Hg plus O2. Check if the equation is balanced. So here it is not balanced. So now the equation is balanced. Let's take the third example. We have the decomposition of water. That is, water can be decomposed in presence of electric current. So what we will get is the hydrogen gas and oxygen gas. Again check if the equation is balanced. So now the equation is balanced. So in this, the one more example what we can take is the heating of potassium chlorate. So when potassium chlorate is heated, what we will get is KCl plus oxygen. So the equation is not balanced, so we need to balance this. So now the equation is balanced. So these are some of the examples of decomposition reaction. Third one is displacement reaction, which is also called as substitution reaction. So it is a reaction in which more reactive metal replaces the less reactive metal from its compound. Okay? It can be represented as A plus BC gives AC plus B. Now for this displacement reaction, you should know the reactivity series. Okay? So here I will write the reactivity series. So K is potassium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver and gold. So here potassium is most reactive and gold is least reactive. So here the reactivity series goes on decreasing. Okay, so potassium is most reactive and it goes on decreasing wherein you will reach to gold, which is least reactive. Now over here hydrogen is used for comparison. So we can say that the elements above hydrogen, they are most reactive and the elements below hydrogen, they are least reactive. Okay. Now hydrogen is used for comparison, and so wherever we have the most reactive metal, it can displace the hydrogen from water, alkali and acid. So here let's take the first example. We have zinc plus copper sulfate. Now this copper sulfate should be in a solution form. We can call it as salt solution. So now let's see, according to the reactivity series, zinc is over here and copper is over here below hydrogen. So which one is more reactive? Yes, so zinc is more reactive. So the more reactive metal displaces the less reactive metal from its compound or from its salt solution. So what will happen? We will get ZSO4 plus we are going to remain with copper. Okay, let's take one more example. We have Fe plus CuSO4. So now check Fe. Fe is over here, which is most reactive, and copper is over here. So what will happen? The most reactive metal displaces the less reactive metal from its salt solution. So what we are going to get is FeSO4 plus Cu. Let's take one more example. Third one, we have sodium plus HCl. Now here you have sodium, which is most reactive, and here you have hydrogen. Okay. So now what will happen? The most reactive method displaces the hydrogen from the acid, and what we are going to get is NaCl plus H2. Now is the equation balanced? No. So we need to balance this. So now this equation is balanced. Let's take one more example. Fourth one, we have magnesium plus H2SO4. So what will happen? Magnesium is most reactive, so it will displace the hydrogen from the acid, and what we will get is the MgSO4 plus hydrogen. So check if the equation is balanced. So the equation is already balanced. So these are some of the examples of displacement reaction, which is also called as substitution reaction. One, double displacement reaction. It is a chemical reaction in which the two reactants exchange their ions or radicals in the aqueous state. Now what do you mean by radicals? Radicals are the group of atoms which retain the identity in the series of chemical reaction. So let's take some of the examples of radicals. We have ammonium ion, then we have nitrate, we have sulfate, we have sulfite. So these are the radicals, those are the group of atoms. Okay. So now in double displacement reaction, it can be represented as AB plus CD gives AC plus BD. Okay. Wherein AB and CD, these are the reactants, and AC and BD, these are the products. Now in double displacement reaction, there are two different types of reaction. First one is precipitation reaction. Precipitation reaction. Now what do you mean by this precipitation reaction? It is a type of double displacement reaction in which the two reactant, that is in the aqueous solution, forms a new product in which one will be the precipitate. Now what do you mean by precipitate? Precipitate is an insoluble solid mass that is formed during the chemical reaction. So here let's take an example. Let's take the first example. We have NaCl solution plus silver nitrate. So now what will happen? There will be the exchange of ion or the exchange of radicals. So the sodium will combine with the nitrate of silver nitrate, and the silver will combine with the chloride of sodium chloride. So what I will get is, I will get one precipitate, that is AgCl. This is the curd white precipitate. Plus I will get sodium nitrate, NaNO3. Now you need to check if the equation is balanced. So your equation is already balanced. So basically what is happening, there will be the exchange of ion, out of which one we will get the precipitate, that is insoluble solid mass, and the other one will be the soluble solid. Second, let's take one more example. We have barium chloride plus dilute sulfuric acid. So again what will happen? There will be the exchange of ion. So barium will combine with the sulfate of H2SO4 and hydrogen with Cl. So what we will get? We will get barium sulfate. Now this barium sulfate is again high precipitate. So precipitate is given with the downward arrow, plus what I will get is the hydrochloric acid. So you need to check if the equation is balanced. Third one, let's take copper sulfate. Now this equation, when I treat it with sodium hydroxide, what I will get? There will be the exchange of ion. So copper will combine with the hydroxide of sodium hydroxide and I will get the precipitate as copper hydroxide, CuOH twice. Now this copper hydroxide is pale blue precipitate. So precipitate is given with the downward arrow plus I will get the soluble salt. Now here we know from the formula it is sodium sulfate. Now suppose if you don't know the formula of sodium sulfate, then go with the crisscross method. So it will be Na2SO4. So now check if the equation is balanced. So equation is not balanced, so we need to balance it. So now the equation is balanced. Let's take the fourth example. We have lead nitrate combines with ammonium hydroxide. There will be the exchange of ion wherein we will get one precipitate and one soluble salt. So here this lead will combine with the hydroxide and ammonium ion from ammonium hydroxide will combine with the nitrate of lead nitrate. So what I will get is PbOH twice, that is lead hydroxide. So this is the chalky white precipitate plus I will get ammonium nitrate NH4 Na3. So again you need to check if the equation is balanced. It is not balanced, so we'll balance it. So now the equation is balanced. So these are some of the examples of precipitation reaction. Second one is neutralization reaction. So now what do I mean by neutralization reaction? When an acid combines with the base, when it combines with the base to form salt and water. Salt and water. We call it as neutralization reaction. So here acid, when it combines with the base, we get salt and water. So here let's take an example. Acid, suppose if I take HCl and if I take the base as NaOH, what I will get is, I will get the salt and I will get water. NaCl, so this is sodium chloride salt and I will get water. Okay, let's take the second example. Suppose if I take the base as KOH and if I use the acid as H2SO4, that is sulfuric acid, what I will get is, I will get the salt. I will get the salt and here I will get the water. So I will write water first and I will get the salt, that is KnSO4, that is we can say it as potassium sulfate. Now what is the formula of potassium sulfate? Go with the crisscross method. So it will be K2SO4. So check if the equation is balanced. Now equation is not balanced, so we need to balance it. So 2K, K2, then hydroxide, oxygen is 2 and 4, that is 6. So here 4 and 1, so I will put 2 here. So oxygen is balanced, hydrogen is 2 and 2, 4, hydrogen 4. Sulfate is 1, here also it is 1. So now the equation is balanced. Let's go for the third one. Suppose if I take NaOH plus I use HNO3. So what I will get? I will get again the salt and water. So that is NaNO3 and water. So check if the equation is balanced or not. It is already balanced. So this is the type of neutralization reaction wherein we get salt and water. Let us study the applications of neutralization in our daily life. Toothpaste has bases which neutralizes the acid formed in the mouth. Okay, thereby it maintains the oral hygiene. Bee sting causes pain and as it injects the methanoic acid, which is also called as formic acid. So it is acidic. So in order to neutralize it, we can use sodium bicarbonate. Another one, baking powder is used normally in order to bake the cake. That is, it makes the dough rise. So in that case, it neutralizes the effect of carbonic acid. Now if the soil is acidic, in that case, in order to neutralize it or in order to maintain the pH, we are using the base, that is calcium oxide, which is called as quicklime, calcium hydroxide, which is called as slaked lime, and chalk, which we call it as calcium carbonate. Okay. If the soil is basic, in that case, to neutralize it, we are using the sulfate salts. Okay. One more application is, whenever there is acidity in the stomach, in order to neutralize it, we can use antacid, which is also called as milk of magnesia, wherein it can neutralize the effect of acid in the body. So these are some of the applications of neutralization in our daily life. Next is reactivity series. Basically, the displacement reaction helps to identify which one is most reactive and which one is least reactive. So the reactivity series is the arrangement of metals in the decreasing order of its reactivity. Okay. So we should know the reactivity series. So I will write it over here. So here we know that potassium is most reactive and gold is least reactive. So in the reactivity series, it goes on decreasing. So we can say that potassium is most reactive and thereby the reactivity goes on decreasing, and gold is least reactive. So over here, hydrogen is used for comparison. So the elements above hydrogen, they are most reactive and we can displace the elements which are below hydrogen. Okay. So here basically hydrogen help to displace from its water, alkali or acid. Okay. So here let's take an example. We have zinc plus copper sulfate. So over here, zinc is most reactive, so it can displace this copper from its solution. So what I will get is zinc sulfate plus copper. Let's take one more example. If I take iron and if I take copper sulfate, again iron is most reactive, iron is above hydrogen, so it is most reactive, so it can displace copper from its salt solution. So what I will get is FeSO4 plus C. Same way, if I take sodium plus if I use HCl, what will happen? Sodium is most reactive, so it can displace the hydrogen from the acid. So what I will get is NaCl plus H2. So check if the equation is balanced. So now the equation is balanced. So let's take one more example. Suppose if I take copper and if I take H2SO4, will the reaction take place? Now here copper is below hydrogen, so copper is least reactive when compared to the hydrogen. So what will happen? It will not displace. So you can write no reaction. So here we have seen the reactivity series. So you should know this reactivity series. Based on the reactivity series, you can able to write which one is getting displaced and the other byproduct. Let us study oxides and their classification. What do you mean by oxides? Oxides are binary compounds in which oxygen is present as an anion. So we all know oxygen is having the atomic number 8. So what will be the electronic configuration? It will be 2, 6. So it is having 6 electrons in the outermost shell. Oxygen is highly reactive due to its small size. Now this oxygen combines with the metals or it combines with the non-metals to form oxides. So here we have the classification of oxides. First one is acidic oxide. Second is basic oxide. Third one is amphoteric oxide. And fourth one is neutral oxide. Okay. Let's study the first one, that is acidic oxide. When non-metal reacts with oxygen, they form acidic oxide. Now this acidic oxide is formed through covalent bond. Now what do you mean by this covalent bond? Covalent bond is a bond that is formed by the sharing of electrons between the non-metals. So here we can take an example, that is carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide. Now these oxides have low melting and boiling point. Now this acidic oxide, when it is treated with water, what we will obtain is the acid. So here when carbon dioxide is treated with water, we get carbonic acid. Same way, if I take sulfur dioxide, when it is treated with water, what we will get is sulfurous acid, H2SO3. This is sulfurous acid. Same way, sulfur trioxide is combined with water, what we get is sulfuric acid. Same way, nitrogen dioxide combines with water, what we will get is nitric acid. Okay, so these are the examples of acidic oxide. Second one is basic oxide. Oxides of metals are basic, okay, and these oxides are formed through ionic bond, or we can also call it as electrovalent bond, ionic or electrovalent bond. So now what do you mean by ionic bond? The bond that is formed by the transfer of electrons from metal to a non-metal. So we call it as ionic or electrovalent bond. So in this we can take an example like zinc oxide, sodium oxide, copper oxide, potassium oxide, calcium oxide. These are some of the examples. Now in basic oxide, the basic oxides have high melting and boiling point. Now this basic oxide, when it is treated with water, for example, sodium oxide, when it is treated with water, what we get is base, that is NaOH. So check if the equation is balanced. So you can say now the equation is balanced. Let's take one more example. Calcium oxide, when it is treated with water, what we will get is calcium hydroxide. So equation is balanced. Same way with zinc oxide, when it is treated with water, what we will get is zinc hydroxide. Okay, so these are the examples of basic oxide. Third one is amphoteric oxide. So these are the oxide which shows properties with both, that is acid as well as base. So here there are some metals which shows the amphoteric nature. So here we have aluminium oxide, lead oxide and zinc oxide. So this oxide, when it is treated with acid, it undergoes the neutralization reaction wherein we get salt and water. Same way, these oxides, when it is treated with base, again it undergoes the neutralization reaction wherein we get salt and water. So let's take the first example. Aluminium oxide, when it is treated with acid, for example H2SO4, what we will get is salt and water. So here we will get aluminium sulfate. So again, if you don't know the formula, go with the crisscross method. So it will be Al2SO4 thrice plus water. Now check if the equation is balanced. So here I have to put 3, hydrogen is 6. So now the equation is balanced. Same oxide, when I treat it with the base, that is NaOH, what I will get is, I will get the salt and I will get the water. But here the salt what I will get is NaAlO2 plus water. This is called as sodium aluminate. Sodium aluminate plus water. You need to check if the equation is balanced. It is not balanced. So I will put 2 over here. So 2 2s are 4 and 5. 2 and 3 5. So now the equation is balanced. Okay. So here I have taken aluminium oxide. When it is treated with acid and when it is treated with base, we get the salt and we obtain the water. Let's take one more example. Second, suppose if I take zinc oxide. Zinc oxide, when I treat it with HCl, what I will get is, I will get the salt. So here, salt I will get is zinc chloride plus water. You need to check if the equation is balanced. So it will be 2. Now the equation is balanced. So same zinc oxide, when I use the alkali, so here I will use NaOH only. You can also use potassium hydroxide, KOH. So what I will get is, I will get the salt. So first thing I will get water, so I will get water, H2O. So what kind of salt I will get? I will get Na2ZnO2. Now this is called as sodium zincate. Sodium zincate plus water. So this is the salt. Now you need to check if the equation is balanced or not. So 2. So now the equation is balanced. Okay. So same way, zinc oxide, when it is treated with acid and base, we get salt and we get water. So same way, suppose for this zinc oxide, if I use KOH, then what kind of salt I will get? Instead of Na2, I will only replace it by K2, that is K2ZnO2. So what will be the name? The initial one I have written sodium zincate. So what will be the name for this? It will become, correct, it will become potassium zincate plus water. Okay. So again the equation is already balanced. Got it? So these are some of the examples of amphoteric oxide. One is neutral oxide. Now neutral oxides are the oxide which do not show the acidic as well as basic properties. Okay. So in this neutral oxide we have carbon monoxide, then we have nitric oxide and we have nitrous oxide. So these are the examples of neutral oxide. So in this we have studied the types of chemical reactions. Then based on that we have learned the reactivity series and we have learned the oxides and their classification. So here we come to an end with this chapter. Thank you. Thank you.